Okay, I'm Dr. Raymond Mariella Jr. from Lawrence Livermore National Laboratory, and this is a joint presentation with Dr. Lloyd Hackle from Metal Improvement Company, part of Curtiss-Wright Surface Technologies. And this presentation addresses robotic laser surface inspection and decontamination, we call RLSID, which combines LL&L inventions with Metal Improvement Company's laser robotics system. So RLSID does laser decontamination of nuclear and chemical hazards on surfaces, or how to decontaminate a concrete surface remotely. So today, the decontamination of building surfaces lacks diagnostics to locate and measure the depth of contaminants, and it lacks a verification technique to confirm the decontamination of chemical hazards. So RLSID addresses where is the contamination, how deep does the contamination go, and was the contamination successfully removed? So of course, hazardous materials can contaminate buildings and other surfaces by spills and accidents, fires, just plain spills. I'll talk more about this in a bit, but for years, beryllium oxide machine in this building in Ohio, workers didn't know the risk, and the building is sitting there today contaminated with beryllium oxide as well as radioactive materials. And I'm sure most people in the audience remember from 10 years ago that there was a explosion at the Fukushima Daiichi nuclear power station, which released radioactivity into the environment. So existing methods to locate surface contamination and validate decontamination procedures are very limited, and RLSID offers a solution. The RLSID typically removes approximately 1/100th of a millimeter per scan using the laser striking the surface of concrete, brick, paint surfaces underwater. And the operator of the robotic laser is in a separate room. So RLSID entrains chemicals, whether they be beryllium all the way up to heavy metals like uranium, into the water stream that is used in RLSID. And that's available for then real-time analysis to find if the contaminants are actually there. And of note, determining the location of beryllium with or without radioactive contaminants on a surface has been and remains a major challenge, particularly if the surface is porous or uneven, because manual wet swiping is the national standard. While RLSID does work on porous and uneven surfaces, it minimizes the worker exposure to hazards because the worker is not in the same room as the hazard. And this establishes a new as low as reasonably achievable, or ALARA, level for worker safety. RLSID has intellectual property protection with 3 patents issued in 2020, 2 in the US, 1 in Japan. And Dr. Hackle was able to take existing laser systems that are used for laser peening, make the beam bigger, shoot it at concrete using his typical water stream, and was able to bore 1 centimeter deep into a piece of concrete from the Hazardous nuclear reactor in a matter of minutes. And we have used RLSID to measure the concentration versus depth of 6 contaminants on the surface of concrete. So in short, RLSID, this new process, has a higher processing rate than previous laser processes. So today, there are very few fieldable methods to measure the thickness of contaminated surface. Principally, it's done by taking core samples mechanically. And to support this statement, here is a publication from 2019 by Yamada that studied radioactive cesium contamination on concrete in the prefecture of Fukushima Daiichi nuclear plant. And you'll notice they could have chosen any method to do sampling, and they chose drilling a core through the concrete. They then removed the core, took it back to the lab and analyzed it, where they found that the radioactive cesium contamination was limited to the top 2 millimeters of concrete or less. This is a plot of radioactivity versus depth, 1, 2, 3 millimeters deep. And you notice the radioactivity is confined almost exclusively to the top millimeter, which matches well to the removal rate of the RLSID. So RLSID can minimize disposal costs. That's why a company or an operator might care about it. If you have a large, thick block of concrete or a wall of concrete, like in a nuclear reactor, but only the first millimeter or so has contamination, if you can strip off the contamination, you can then dispose of the bulk concrete as low-level waste, which is a significant cost saving. So you scan the laser back and forth across the surface, remove the material, collect it in a little stream. You can see what was left, of course, and go back and make sure it's clean. But this is a cost savings incentive to use this new process. RLSID can work on porous, uneven curved surfaces, just a trickle of water that collects what's being removed. And the processing rate on concrete with this technique is 45 square feet per hour. Now, the same laser that is used for laser peening, which is shown here, would be used on whatever surface of concrete was being treated, but it works already on large curved surfaces. This is about 8 feet by 30 feet. And this was laser peening, but if you make the beam bigger, it could have been made of concrete. So we were seeking a partner for a field demonstration on RLSID. And when I say field, I mean a field demonstration. Metal Improvement already has a complete system that's transportable in 18-wheeler that can go to whatever job site is required to do the operation. So Curtis Wright Metal Improvement is well positioned to expand its business line to include RLSID with very little incremental cost. So there are plenty of opportunities. I mentioned Lucky, Ohio was contaminated with beryllium, lead, radium, and so forth. Taxpayers have already spent more than $240 million, and they haven't even tried to decontaminate the inside of the building. That's just to deal with the leaks coming out of the building. The 3 Mile Island nuclear plant 40 years ago had a nuclear accident that contaminated the inside walls of the containment building, the concrete walls, and they're still sitting there contaminated, waiting to be decontaminated after 40 years. The Hanford site in Washington, which has decommissioned nuclear production complex storage tanks, is filled with mixed waste, that is hazardous chemicals with radioactivity, and all the surfaces, even if they can manage to pump out and vitrify what was inside of them, the metal still needs to be decontaminated. So these are all markets for RLSID. So what would it cost? RLSID, using the Metal Improvement Company laser, scans 45 square feet per surface, and I'll show you that works out to about $10 a square foot. So 45 square feet per hour is about 1,000 square feet per day, and the cost of such a laser system by industry would be more than $200,000 a month because they have to pay for payroll, facilities, and all the costs of doing business. I've rounded up to $250K because we have to add the cost of doing the water analysis as it's flowing. But if you run 25 days in a month, that's about $10,000 per day. That's about $10 per square foot. Now, the cost increases proportionally if you have to do multiple scans, except that once you've determined that a surface is clean, you don't have to go back and do it again. So we seek a partner for field demonstration. Why? Because every society we've contacted or government agency has said we need to perform a field demonstration to get full credibility of our costs and performance. This is necessary for RLSID commercialization. And if you want more information, contact Mr. David Dawes at LL&L.